Hello and welcome back once again to this Hadoop series of Hadoop Made Easy. So this is the third video in this series and the prerequisites are the first and the second videos, and hope you watched it. In case if you haven't watched it, so please make sure to watch those two videos before watching this, in case if you are new to the world of Hadoop. So in this video I'm pretty much going to discuss about the backbone, what is actually called as the backbone of Hadoop. As I told you, like, Hadoop actually is a framework, it's a software framework running on a cluster of distributed computers. So the way the jobs actually gets executed in this Hadoop environment or in this distributed environment is by using something called as map and reduce. So this is pretty much the backbone, the way the jobs gets executed in the world of Hadoop. So we are going to discuss a problem to understand how MapReduce works. So MapReduce, you just have to be clear with it. It's just a programming approach. It is not a programming language feature as such. Like, MapReduce can be done in any programming language. But in this video, I'm not going to speak about the programming aspect of MapReduce, but I'm going to speak only in terms of the algorithmic aspect of MapReduce. So let's get started with a simple file or a simple problem statement. Say that we have an input file. The name of the file is going to be like secret.txt, and the file just has 2 lines of data, and the data present in the file basically includes: this is not a secret if you read it, that's the first line; it is a secret if you do not read it, that's the second line. That's it. The file is a simple file, it's a text file just having 2 input lines in it. That's it. And the problem statement is we need to count the frequency of the words in the file. So the expected output is like how many times each word is repeated in the file. Like, the word this is repeated once in the expected output column over here. The word is repeated twice, and the word not is repeated twice, and the word or the letter A is repeated twice, and so on. So if you actually process a very large input file with, let's say, 1,000,000 lines in it, so you can imagine what the expected output could be. So the problem statement is word count, or it's simply to find the frequency of words in a file. So how we shall actually see in the subsequent slides, how do we solve this problem in MapReduce? MapReduce is basically a way, it's a paradigm, it's a technique of programming in a distributed computing environment. So let's see what happens. So in the world of MapReduce, it's a 2-stage approach. Map is the first stage and reduce is the second stage. So we're going to see what happens in the map stage. Now within the map stage, there are 2 substages. The first stage within the map stage is going to be the record reader. Now record reader actually is a component. It's basically a software component which reads one line of the input file at a time and does something to it. It does something to it and produces a pair of outputs. Basically, it produces 2 outputs after processing each line of the input file. Now the first output will always be a number, and the second output is going to be the entire line. So let's actually examine what is the first output and what is the second output. So the first output is called as a key, and the second output would be called as a value, and these are just the naming conventions. As I just told you a few seconds ago, that the record reader is going to produce 2 different kinds of output after reading every single input line one at a time from the input file. It's going to produce 2 outputs. The first output is called as a key, which is always a number, and the second output is called as a value, which is the entire line which it has read. So the key here is called as a file offset, and the value is going to be the entire line. So the original contents of the file was like, this is not a secret if you read it, that is the first line, and that's now which is outputted, or this is the output of the record reader. So the key and value, the record reader is going to give you the output in terms of key and value. The key is a number, which is 0 in this case, and the value is going to be the entire line. In this case, it's the first line of the file. Remember, a file actually had 2 lines. The first line of the file is, this is not a secret if you read it, and the second line was, it is a secret if you do not read it. So we're just dealing with the record reader processing the first line of the file. Now let's try to understand what exactly is this key, and why is this key 0 here, and why it's actually called as a file offset, what exactly the file offset means. Now, for example, let's consider a different file. Assume that this file actually is having three input lines, which is actually highlighted in blue over here. So the first line, the contents of the file is like, it's a new file, and the second line of this file is, it has two lines, and the last line, these are pretty much the contents of the file. Now each character in the file occupies 1 byte of data. The first character of the line starts at location 0, which is actually called as a file offset. So if you actually try counting the number of characters in the first line, IT, the apostrophe, and S is 4 characters, and the space occupies 1 character. So it's followed by space occupies total of 5 characters. And the letter A occupies 1 character, followed by space, a total of 2 characters. So on, if you keep adding the total number of characters, like, and 1 character for every space, and then 1 character for a new line, what would happen is there would be total of 16 characters in the first line. So it's 1, 2, 3, 4, space 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the new line, when you press the enter key, when you're trying to type something into the file, there would be an invisible character which would be printed onto the file, which we cannot read. It's actually called as a new line character, and it occupies 1 byte. So totally it is 16 bytes long, and it's pretty obvious that the next line, or the first character in the next line, is going to start from 16 plus 1th location, which is going to be the location 17. So this is actually the meaning of file offset. So whatever the record reader processes would be the first line, and it would be giving you the output in terms of key and value, where the key is a number and that number is going to be a file offset. So now you must be able to calculate what would be the file offset for the second line, the third line, and so on. So the record reader does a very simple thing. It reads a line, produces the output in terms of key and value, where key is a file offset and the value is the entire line. Now MapReduce is a 2-stage process, where map is the first stage. Now within the map stage, we have 2 substages. The first substage was the record reader. We pretty much saw what a record reader does. It's pre-programmed to do this thing. And then the output of the record reader has to go to another module called as a mapper. Now mapper is actually the second substage of the map stage. Now map and reduce are the 2 major stages in MapReduce. Within the mapper, we have 2 substages. First one being the record reader, the second one being the mapper. Now the output of the record reader is pretty much what is fed as the input to the mapper. So the mapper accepts a pair of inputs, which is a key and the value. Now this guy, the gray robot over here, the curious looking guy, or the confused looking guy, whatever you say, this guy, the mapper, is another software component, and it can be programmed. The mapper can be programmed. So what exactly you can program the mapper to do depends upon the problem statement. So the mapper accepts input in key value pairs, and it also outputs the results in key value pairs. What it actually outputs depends upon how it's going to process the input, and how it's going to process the input depends upon how you're going to program the mapper depending upon the problem statement. So going forward, we must be able to see how we are going to program the mapper. I'm not going to explain why I am programming the mapper this way, but by the end of the slide, you'll be able to understand why the mapper actually was supposed to be programmed this way in this example of word count. So in this particular example of trying to find out the frequency of the words, or the word count in an input file, these are the 3 algorithmic steps, or the 3 logical steps what I would ask the mapper to do. We all know that the input to the mapper is going to be key and value, where key is going to be 0 for the first line, which is a file offset for the first line of the file. And this is not a secret. If you read it, it's the original contents of the file, the first line, the original contents of the file. So who's giving this output? The record reader. So the output of the record reader goes to the mapper, and in the mapper, I actually instruct the mapper like to ignore the key given by the record reader for some reason. I don't want the key. Then the second step is like extract each word from the line and produce the output in key value pairs, where the key is a word of the line and value is going to be 1. Mind you, this steps 1, 2, and 3 is actually the logic what I'm trying to embed into the mapper, or I'm programming the mapper according to these three logical steps. And it's not necessary that for all the problem statements or for all the kind of problems, this is the same kind of steps. No. So when we discuss more and more MapReduce problems, you will be able to intuitively understand how am I supposed to program the mapper. For time being, just understand that I am programming the mapper this particular way. At the end of this video, you'll be able to understand why was the mapper programmed this way. And when we discuss more and more problems, it should be clear. For this particular problem statement, I'm asking the mapper to ignore the key from the record reader and then extract each individual words from the input line, that is a value, and output each of those words as a single key, and its associated or its corresponding value would be a number which is 1 or a digit which is 1 for this particular problem. So when the mapper actually applies the programming logic mentioned in steps 1, 2, and 3 on this particular input, this would be the output. So the input to the mapper is going to be the file offset, and this is not a secret if you read it, the first line of the file which is processed by the record reader. As per the program, as per the logic what I've asked the mapper to implement on this input, the mapper would output the first word, which is this, followed by 1. So this is a key and 1 is a value. Is going to be the first, is going to be another key and 1 is going to be the value. Not is going to be another word and 1 is going to be the value. So on. After it processes the entire input, this is going to be the output. So the output of the mapper is going to be in key value pairs. So the mapper accepts key value pairs and produces key value pairs as output. So how it's going to produce the key value pairs or what it is going to produce the output as key value pairs depends upon the problem statement. Depending upon the problem statement, you're supposed to program the logic into the mapper. So I hope it must be clear until now and going forward to the next slide. So after the mapper processes the entire input file, this is what the output is going to pretty much look like. So the file offset for the first line is obviously 0 and the file offset for the second line is going to be 37, which is going to be output by the record reader, one line at a time. And the mapper would actually keep all these things. The output of the mapper will be present in a file, which is actually an intermediate output file. So this is what it's going to look like. For every word in the line, every word in the line is considered to be a separate key, and its corresponding output, its corresponding value is going to be 1 for this particular problem. And mind you, for all the problems, the key and the value could be different. I mean, for different kinds of problems, the key and value could be different. So it's not the same logic for all different kinds of MapReduce problems. For this problem, I'm programming the mapper to do this kind of a computation. Now going forward, what would happen to the output of the mapper? Now, you have to understand that we are trying to solve every problem in a distributed computing environment. So we're going to have a cluster of say 100 or even like 500 computers interconnected. If you ideally try to input a file which is of size 640 MB, by default the file would be split into smaller chunks of 64 MB blocks. There would be 10 input splits. So who does it? The HDFS manager, or the HDFS does it. The Hadoop distributed file system manager takes care of like splitting up this large input file into smaller chunks of 64 MB and storing them on individual data nodes. So 10 different data nodes on this 100 node cluster, for example, would be storing or would be having these input splits. Now, there would be one instance of mapper code which would be processing all of these input splits on each of the data nodes. When I say one instance of the mapper code, it's the mapper which you have programmed. You have written the program into the mapper and asking the mapper to do something. So this mapper would be running on each of these data nodes, or 10 different data nodes containing these input splits. They would be running independently. Now the output of these mappers running on these individual data nodes will have to be aggregated. They have to be combined into a single file. So all of these intermediate data which is generated as an output of computation of the mapper code will be sent towards or will be sent to a single computer, which is actually another data node in the system. So all of these intermediate files will be sent across the network because it's an interconnection of 100 computers. In this example, we have 100 node cluster. So it should be sent to a single node where the reduce operation would be running. So in this way of map reduce problem solving, map is the first stage. Within the first stage, we had two substages, record reader and the mapper. And then we have the second important stage, which is called as a reduce operation, or the reduce stage. So the reduce stage happens on a single machine. By default, we would just be having a single reducer. So going forward, we are supposed to explore what exactly happens in the reduce stage. Reduce stage consists of three different stages. It's actually called as sort stage, a shuffle stage, and then a final reducer operation, which we are going to explore in detail. So we are done with the mapper stage. The output of all the individual mappers is now sent to a single data node in the cluster, and then all of those files are supposed to be combined into a single file. And on the single file, on that data node, three different operations will be done. The first operation is going to be a sorting operation, the second is going to be called as a shuffle operation, and then the final reducer operation. So all this combined together is called as a reduce stage. So reduce stage consists of three substages. Now let's understand what exactly happens in the first substage. It's called as sorting. In the sort stage, consider the simple example. We have an intermediate file of a mapper which is consisting of name and age as keys and values. Katie is 34 years old, and Alice is 10 years old, and Bob is 89 years old. So what the sort module, or the sorter, by default it is programmed to sort the key value pairs, but it would not consider the values. It would only consider sorting operation based on the keys. So don't confuse that keys are separate and values are separate. Of course they appear separate, but both of them, like the key and value, are associated together as a single entity. Now when you sort them, they get sorted as a single entity, meaning the Katie, Alice, and Bob are basically the keys. The sorter would try to sort them in the alphabetical order. So the output would be Alice, Bob, and Katie. If you notice, when Alice actually gets sorted, the value associated with value will automatically be along with the original the key itself. So Alice 10 comes on top here, Bob 89 is the second guy here, and Katie 34 is in the last. If you notice here, 10, 89, and 34, the values are not sorted. It's only the keys which are actually sorted, and the original values associated with the keys will stay with the key in whatever orders the keys are actually sorted. So this must be pretty much clear, like what happens when the intermediate output of the mapper goes through a sort phase. So this is a simple example for the sake of understanding what a sorter does. If the same kind of operation is performed on the intermediate file generated by our mapper in this example, this is what it would actually look like. This is the input to the sort phase. Like the input to the sort phase is going to be pretty much the output of the mapper, and this after sorting would look like this. So if you look here, I'm just trying to toggle the slides. This is before sorting, like the keys are not sorted here. If you go forward, if you see, the keys are actually sorted. So the output of the mapper would now go as an input to the sort operation. And sort, this is what is the output. We are going to sort the key value pairs based on only the keys here. So the keys here are sorted in the alphabetical order. Now the output of the sort is going to another stage called as shuffle. Alright. So let's take another simple example to understand what happens in the shuffle phase. Now, if you consider the shuffle input to the shuffle phase to be like a set of key value pairs. Apple, there are 2 apples, and another instance of apple, there are 4 apples. So you can consider them as green apples, the other as red apples, mango, count of 1, and oranges, 11 oranges, which is like, say, small size oranges, and then you have another 6 oranges, which are like large size oranges. So you just have an input file in key value pairs. What happens if you actually pass this input, which is basically a key value pairs, to another module called as a shuffler? What the shuffler does is like it tries to aggregate the duplicate keys. So we have apple repeated twice over here, but if you see carefully, apple is appearing just once, what is happening to the values associated with each instance of Apple in the left hand side. It's chained. Basically, they are grouped into a list of values. Mango, there's just one instance of mango, so nothing is done to it. Oranges, again, there are like two instances of oranges here, but those values are again now grouped into a single list of values. So the shuffle operation is also called as aggregation operation, or it's just the removal or aggregation of duplicate keys. So the output of map stage is now going as an input to the reduce stage, and reduce stage consists of three different substages. The first one being the sort, where sorting happens based on keys, and then after sorting, the output of the sort module is now going to go as an input to the shuffle module, where in the shuffler it's just an aggregation of duplicate keys, or duplicate keys are eliminated and the corresponding values are chained as a single list of values. Now obviously the next question is, what would happen to the output of this shuffle stage? So this is how it will look like. In our discussion, we pretty much had a sorted output of a sort stage for our problem discussion of word count. Once it goes through a shuffle module, it's going to look like this. You see the alphabet A is repeated twice, but now it's appearing just once over here, whereas the values are chained together. Do is repeated just once, and if is repeated, the value if is repeated twice over here, but over here if is just repeated once, and you can see what happens to the list of values associated with if. So you can see, you can pretty much have a detailed look at what's happening to the output of sort phase, which is going as an input to the shuffle phase, and output of shuffle phase is pretty much going to look like this. So the reduce operation consists of three substages. The first substage is going to be the sort, and then it's going to be a shuffler, or the shuffle, or the aggregator. The shuffle is also called as an aggregation of duplicate keys. And then the final output of shuffle phase is going to another module called as reducer. So the output of shuffler is provided as an input to the reducer, and reducer is the final operation of the reduce stage. So map and reduce are the two major stages, and within map we have two substages, record reader and mapper, and then the reduce stage consists of three substages, or three phases, one being the sort, the other being the shuffle, and the final operation being the reducer. So what exactly is a reducer? Now reducer, just like the mapper, is another module which can be programmed by the user depending upon the problem statement. But the condition is that the reducer accepts input only in terms of key value pairs and produces the output only in terms of key value pairs. So what exactly the logic, what the reducer has to perform on its input to produce a particular output depends upon the problem statement. Just like we could program the mapper, we can program the reducer as well. This robot guy over here, or this robot which is like a sober looking robot here, can be programmed as per the problem statement. So going forward in this particular problem, what was the original problem definition, or the problem statement was to find out the frequency of words in a given input file. So we know that the input to the reducer is going to be the output of the sort and shuffle phase. So what exactly appears in this left hand side is pretty much going to be the input to the reducer. By looking at this, you must have taken a guess by now, like, how am I going to get the frequency of the words in the file? Very simple. We just have to add up the list of values associated with every key. That's what I'm going to do right now. Step 1. The input to the reducer is going to be one line at a time from this file. This is actually a file. The left hand side thing over here, the output of sort and shuffle phase, is a separate file. So one line at a time is going to be given to the reducer. So the first input to the reducer is going to be the first key value pair. The key is going to be the letter A, and the value is now going to be a list of values, which is like 1, 1. Step 2, the reducer must just add the list of values from the input, that is sum is equal to 1 plus 1, and then output the original key as a key, and then the value must be the sum of the values. So the output of the reducer is pretty much going to look like the letter A followed by 2. So we pretty much have to repeat the operations in step 1, 2, and 3 until we process all the lines of this file. So it's going to output do and 1 for the second line. It's going to output if and 2 for the third line, and so on. So in the next slide, we're pretty much going to see what is going to be the final output of the reducer. This is an input to the reducer, which is like after the sort and shuffle phase, and then this is pretty much going to be the output of the reducer. A, 2, do, 1, if, 2, is 2. So this is what was the expected output. What is in the right hand side? The reducer output, which is the final output, is what we were expecting the output of the final program. Or we have got the results. We have got the frequency of the words in the input file. This is what we expected to do out of MapReduce. So how is MapReduce helped us to actually improve the performance? Is like we are not processing the input on a single machine. If you recall back, if we input a 640 MB file, it's going to be split across 10 different files, and we are going to process each individual split separately and independently. The mapper code is going to be running on each of those individual data splits. In that way, we are increasing or speeding up the performance of computation. So this is a summary of everything. This is like you have the original input file. It's going to be processed by the record reader, which is going to give you key value pair as outputs. The key is going to be the file offset. The value is going to be the entire line, no matter whatever is present in the file. It need not be a text file. It can be any kind of file, but the record reader is just going to give you a file offset and the entire line as the output, which is going to be consumed by the mapper. And the mapper is also going to give you key value pairs, and the mapper can be programmed as per the problem statement. And the output of mapper is going to go to a sort module, and the output of sort, where sorting happens only based on the keys and not on the values. The output of sort is going to go as an input to the shuffle phase, where shuffle phase is also called as an aggregation phase, where duplicate keys are eliminated. And the output of shuffle phase is going to go as an input to the reducer, and the reducer can again be programmed depending upon the problem statement, and the final output of the reducer is going to be in a directory where we have the final output file. So all these operations on top, reading from an input file, input to the record reader, and input to the mapper, all these three operations on top or the two operations on top belong to the map stage, and all the operations in the bottom, the sort, shuffle, and reducer, belong to the reduce stage of MapReduce two-stage operation of solving any problem in Hadoop. So this is the final summary of everything what actually happens in MapReduce. Input file is read by the record reader one line at a time. If the input file is greater than 64 MB, then it is split into multiple blocks of 64 MB each. And mind you, the 64 MB number can be configured to toggle between 64 or 128 depending upon your problem need. For this problem, we just pretty much keep it as 64 MB. Now each block will be treated as a separate input file, and there will be one record reader and mapper working on each of these input splits on a separate data node. And what exactly the mapper is supposed to do on this input split is the mapper can be programmed as per the problem statement, as per the problem definition. Now the intermediate output files of all the mappers would be sent across the network to one data node for the final reduce operation. And the reduce operation, or the reduce stage, consists of three substages or three operations. The first being the sort, the second being the shuffle, and the third being the reducer logic. Now by default there would be just one reducer running, and we can have, by default there would just be one reducer running, and we can have more reducers based on the problem statement. For this problem, just let's understand that there's just going to be one reducer, and we have to program the reducer based on the problem statement, and the final output of the reducer is going to be the final output what you're going to expect out of the problem statement. So that's it for now, and hope you enjoyed it. Goodbye.